All right, guys, we're going to talk about 11.5 today, common logarithms. In the email, I told you that your homework from today and 11.6 are both due on Sunday. This isn't because I'm making homework on Sunday, it's because I'm giving you guys a couple extra days to get it in, okay? So if you could just have it to me by the end of the day on Sunday, that would be great. So 11.5, we're going to start on the top of page 726 in your book. So if you could get there real quick. Okay, we're going to talk about pH levels of things. So it says drinking water is routinely tested for its pH level. The pH of a solution is a measure of acidity and is related to the concentration of hydrogen ions measured in moles per liter. So I'll just pop this up here. So you can look at see the different acidity of things. More acidic lemon juice will be up here in the 2.2s, and then the pH this way we get to drain cleaner and household ammonia. Isn't that lovely? Testing the water's pH level might indicate the presence of a contaminant that is harmful to life forms. We'll talk a little bit more written down, but there are ways to convert and work with pH level with logarithms. So that's why it popped up today. So, all right. A common logarithm is a logarithm with base 10. If it is not, if no base is indicated, assume it is base 10. So this just says no base. Okay. So for example, you'll just see log with no base, then it is a base 10. You can easily find the common logs of integral powers of 10. So let's work on this chart. We'll get back to the pH. Whoops, sorry for the earthquake as I sat down. Okay. We'll work through this chart and it'll make sense. So log of 10, if we want to find out what that is, log of 1,000, if we want to know what that is, we could change it to exponential form. So 1,000, this right here, there's no base indicated, so it's an imaginary 10. Okay. So we could say 1,000 equals 10 to what power? We know that 10 times 10 times 10, 3 zeros, 10 to the third equals 1,000. So we know that log of 1,000 is equal to 3. Remember that logs are just wanting to know what this exponent is. Okay, so log of 100, we could rewrite this as 100 equals 10 to the second power. So we know that log of 100 equals 2. Log of 10, which would be 10 equals 10 to the first power, so that's 1. Okay, this is log 1 equals 10 to the, anything to the 0 power equals 1. Now we're going to get into our decimals. So when we get into decimals, we're thinking fractions to get our decimal numbers there. So, sorry, not fractions, negative numbers and fractions. So we'll have 0.1 equals 10 to the what? Well, 0.1 is 1 over 10. So to get to 1 over 10, we would need a negative 1. So that'd be a negative 1. I know some of you have looked at this on your on past homeworks before. This concept just kind of popped up. Log of 0.001, 0.01 equals 10 to the, well, it's 1 over 100. We knew that 100 is squared. To make it on the bottom, we need a negative, so a negative 2. And log of 1,000th, 0.001, 1 over 1,000th. So that's 3 places, okay? 1,000th was to the third. To make it a fraction, we need a negative, and that's our answer. All right. So this is how we can solve logs if we don't have a calculator, okay? Or if we need to know some decimals. Okay. Remember that a logarithm is just an exponent. Okay. So this hopefully helped to cement that into your head a little bit. So here's the example for you. Log x equals y, and 10 to the y equals x. Because there is no base notated here, it is a 10. When we have a log with no base and base 10, that's the log on our calculator. So that's when we can use logarithms on our calculator. Example, given that log 7 equals this, evaluate each logarithm. So let's separate 7 million into 2 components that will help us to be able to solve, okay? So I'm going to separate it into log of 7 times log of 1 million. All right. So now we could separate this out. Remember, we just add them, so we could have log of 7 plus log of 1 million. Okay. Well, let's go back to up here. To convert log of 1 million, to solve it, 1,000 was 10 to the third, so 1 million would be 10 to the 6th. So we can have log of 7 plus log of 10 to the 6th. You had some of these on your assignment. If you have log base 10 to the 10, these two in a sense cancel each other out and leave you with a 6. So this right here will be a 6. Log 7 up here told us it was 0.8451. So now we just need to add those together, and our answer is 6.8451. So log of 7 million is equal to 6.8451. All right, now let's take a look at this log. So let's do this one a similar way. Okay, so 7 times 0.0001. Okay, then we can separate it out to have log of 7 plus log of point. I get so excited and I get things shaken. Okay, 0.0001. 0.0001 is a form of 10 from up here. 0.001 was to the -3. We have one more 0. So that'll be to the -4. Log of 7 plus log of 10 to the -4. Sweet. Log of 7 we know is just 0.8451. The log and the 10 are going to cancel each other out, so we'll just have a -4 left. Okay, so we'll have -4 plus 0.8457. We could throw that onto our calculator. 5,1 plus -4. That's going to be a -3.1549. Remember, because we have a negative and a positive, we can't just add them together. we can just add them together, but they don't just become one number like over here. Okay. Note for you, the log function on your calculator is in base 10. I already said that, but there you go for that note again, just so you can write that down. All right, back to our pHs, like I told you we would get to. If water being tested contains 7.94 times 10 to the 9th moles of H plus, so I think that's hydrogen, per liter, what is the pH level of the water? Okay, this is how we solve for pH. So on this calculator, on this problem, this is our H plus, 7.94 times 10 to the negative 9. Okay, we legitimately plug that in to this part of our problem. So to find our pH, we would do log of 1 over 7.94 times 10 to the negative 9. Okay. On this one, I don't want to worry about doing this in my head, so bring out the calculator. We can type in, right here is the log button. Let's see if you can see it, log. So we put in log, 1, we need a fraction, 7.94. Remember, we can just type this in exactly like it says, to the negative 9, solve, and it will give us an answer. Now, did I type something in wrong? No. Let me see if my mode matters. My answer's not right. So says the book. I don't think this should matter. Okay, now I have to figure out what I typed in wrong. Times 10 to the negative 9. Oh, nope, that wasn't it. What in the world? Now it's telling me I should have done second EE. Let's see if I can find that. Okay, let's try this instead. Instead of times 10, I'm going to put this EE button in. I don't need this either. Oh, I don't need that either. Ah, there we go. Okay, so the times 10 to the is the EE. I'll show you where that is. So our pH for this one, I love learning new things. It's an approximation. So our pH is approximately 8.1. To get this part on your calculator, there's a button. Mine was right here that says EE. So you want this to use the EE, okay? And you plug it in for times 10 to the, this whole part becomes this EE, and that'll help get you the right answer, okay? That's how you put the scientific notation into your calculator. All right. Next page. Use the property of logs that we've learned last chapter to simplify. When you can't simplify these anymore, use a calculator. Okay, so on this one, when we multiply logarithms, we can separate them out. So we can have log 5 plus log 2 to the 3rd. when we have an exponent out front, we can put it in front. So we can have log 5 plus 3 log 2. Okay. At this point, we can't do any more solving. This just wants you to work on your logarithm properties. Okay, so now we can put them in our calculator. Log 5 plus 3 log 2. Solve. Comes out with an answer of approximately, in our book it rounds it to 4 decimals. I don't know why, but it does. 2, 1. Okay, so there's your answer. So this is just working on your properties, remembering what your properties are. Okay. All right, when we divide a logarithm, it's the same as subtracting them. Okay, and we can pull this out front. Okay, now we can throw this in our calculator. 2 log of 19 minus log of 6. Careful with your parentheses. Okay. All right, so there you go. Just practicing our properties. Okay, so the graph of y equals log of x can be graphed on our calculator. If you throw it on your calculator, it's going to look something like this. This is the information that is important about it. Your x-intercept will be at 1, 0. You'll have a vertical asymptote at x equals 0, so right here. Okay. Your domain, so your x's, are going to be all positive real numbers, so pretty much anything greater than x greater than 0. Your range is going to be all real numbers because these arrows, it can technically hit everything there. I'm going to put x is greater than 0. Okay. And like I said, this can be graphed on your calculator. All right. When you show me a picture of it, really important that it's skirting along the right number, whatever you graphed, and that you plot a point that is supposed to be where it's at. Okay. Make sure you have a label of your axes so I know what those are. Okay. All right. Change of base formula. This formula is really helpful so that you can put things in log base 10 so that you can then use your calculator. Okay, because remember, if you had a log with a base of 2, for example, you can't use your calculator. So this formula helps with that. What it says is we're assuming that A, B, and N are all positive numbers, and A and B are not equal to 1. Okay. So this is saying you have some log, base whatever, 12. If you do log of whatever base you want now, so usually it's just base 10 of your number over log of the original base, that will help you to be able to change the base to a different one. Okay, let me show you exactly what that means right here. Find the value of this using the change of base formula. So what we're going to do is we are going to use log base 10. So I'm just going to write log. This will allow us to use it on our calculator. All right. So we're going to do log of this number, the number next to the log, divided by log of your base. Okay. Now you can just take this straight and put it in your calculator, and that will tell you what the answer to this is. That's why we love the change of base formula. Okay, so this is approximately 3.163 is the answer to whatever log base 9 of 1043 is. Okay, that's how simple change of base is. It'll do a bunch of problems so you can practice through them. Okay. All right. Logarithms can be used to solve exponential equations. So here's our exponential equation. We are going to use a logarithm to solve this exponential equation. Okay? So what we're going to do is, to get rid of this exponent, we are going to take the log of both sides. So we're going to go log of that, log of that. Okay. We can take this 3x then and put it in front. So 3x log of 6 equals log of 81. Okay. We used regular log with a base of 10, so we can eventually use our calculators. Okay. Now we just solve for x using equation methods. If you can wait to plug these into your calculator, okay, that's the best, so that at the end you don't have any rounding. So then we'll divide by 3, we'll divide this by 3, and then that will give us what x is approximately. Okay, so then we'll throw this in our calculator. We have log 81 divided by log of 6, and then we're going to divide that by 3. So it's approximately 0.8175. Okay. Okay, this one says to solve by graphing. When it asks you to solve by graphing, what we're going to do is we're going to use two equations to plug into our calculator. So we're going to use that y equals 5x to the negative 1, y equals 2x. Okay. We are going to now, I'm going to scoot this over so you can see my calculator. We're going to plug those into our calculator. Okay. Because it says we want to know when they're equal, we're going to plug two equations in and find out where they intersect. So we're going to say 5x minus 1. Make sure you use your parentheses so that you have the right thing. Here's my graph. Okay, that didn't help me because I had some crazy window. Put a standard window. See if I can even see my equations. Oh, yep, I can. Okay. So what I could do is I could trace to find out when they intersect. If you want to find an actual intersection point, you can push second calc. So we need to find where they intersect. To find the intersection, you push second calc, you go down to intersect. Okay, it'll ask, is this the first curve? Then you're going to push enter, make sure it's on the first curve. Is this the second curve? So did I move to the second curve? Probably did, just peek. You want it to guess? So you push enter again, so enter 3 times, and it's going to tell you where those points meet. Okay, so we want to know what x is. X is approximately 1.7565. Okay, there we go. So if it says solve by graphing, that's all you do. Sweet. One more concept and then we are done for this lesson. So the last thing I want to talk about is an anti-logarithm. Okay. Remember, if something's anti, we're talking about when it says like let's say we do anti, like sine to the negative 1. We're talking about anti there, and we're really talking about the inverse. Okay, that's what we're doing here. An anti-logarithm, you'll see it written like this. Anti-log of a equals x. Remember that log of x equals a. Okay. just kind of doing the inverses there. What it really is this anti-logarithm is just saying, because this doesn't have a base 10 to whatever this is equals x. So anti-logarithm is just another way to pretty much write our exponential. Okay. So it'll say the anti-logarithm of this. So we're just going to use this concept right here. We're just saying 10 to this. Oh, that's a 0. 0, 6, 0, 0. Okay. And then legitimately taking that and throwing it into your calculator. So saying you can push that button right here underneath the log is the anti-log button. All right. But it is just the same as saying this as well. We'll get the same answer. You can just do 10 to or use that button. So this answer is approximately this. Okay. On our logarithms in our homework today, they are rounded to 4 decimal places. So just round everything to 4 decimal places. So the answer to this one is, because this would round, so this is 0.871. All right. Here's your homework assignment, page 730, number 19 to 21, 29 to 45 odd, and 57. I will send you the answers to number 20 in the email so that you have it. This is due by 4/26. Send me your score. Okay, if you want to send your score sooner, please do. I just want to make sure you guys have plenty of time before we start the next week. All right, if you have any questions, send me an email and I will talk to you guys later. Bye.